Hello, everyone, and welcome to this session. Hello, Atefe. How are you doing?
I'm good. Hello, everyone. Welcome to the Montreal Power BI Connect meetup. We are thrilled to have you all with us today.
Yeah, so welcome, everyone. We have an amazing speaker today that will join us in a few seconds, in a few minutes. And first of all, please tell us if you can hear us. Tell us if everything is working properly. So you have the chat. I see we have a lot of people on LinkedIn. We have few people on YouTube too. Just let us know if you can hear us clearly before we start. So in a few, we have just let us know if it works, and then we will get started very quickly. So we have Lina. Hello, Lina. Welcome. Tierno, welcome. Javier, welcome. Olivier from Paris, welcome. Adama, Aisha, Frederic, Dominic. Oh, there is a lot of people in the chat. That's amazing. Noria from the US. Alain. Okay, so it seems like it works. Damien from Montreal. Amazing.
Yeah, that's amazing. We have lots of people today with us. Sorry, first when I started, my voice was repeated. That's why I should close and again back to the stage.
Okay.
Yeah, so we can continue. I will continue without my mic. So is like okay. So we have amazing guest speaker that we will invite into the stage soon, and in just a few moments you will see him. And probably about our meetup, this is still our meetup is still in early stages these days, but we are excited to build something special together. Yeah, with you, with all of you. Yeah. So Ben will explain about our meetup more. Ben, it's yours.
Absolutely. So, very briefly, before we begin, this is the Montreal Power BI meetup, the Power BI Connect meetup, and our goal is very simple: is to share our passion for Power BI, and we have amazing guests. Like today, you will see we have an amazing guest that will join us in less than 1 minute. So we are still a young meetup, but we have a good growth those days. So that's amazing. So right now we have the pleasure to welcome an amazing speaker. So hello, Nicolas. Welcome to this session.
Hi, hello, hi, bonjour.
That's nice.
That's the only thing I know to say in French, and of course, merci. Yeah. Yeah. Hi, and thanks for inviting me. And what I want to say is fully support your initiative, guys. It's the best possible thing you can do is to share the knowledge with others. So it's amazing initiative to run this Power BI user group. I'm happy to be with you here today.
Yeah, and thank you. Could you please start and tell more? We want to learn more about you and what you have for us today. So, stage all yours now.
Sure, absolutely. So yeah, maybe I can start sharing my screen and then I'll do a short intro about the session and about myself. So let me share the screen, and I hope you are able to see it now.
Yes.
Okay,
Yes.
perfect. Oh, perfect. Then yeah, let's start. And again, hi everyone. Good evening, good afternoon, good morning, because it's virtual meetup. I don't know from. I see in the chat that people are joining from all sides of the planet. So wherever you are, I wish you good part of your day, current part of the day. And as I said, extremely happy to be with you. And I believe it's a quite important topic to understand how Power BI works behind the scenes, and trying to share with you some best practices to keep your Power BI data model size in optimal condition. So that's the goal of this session. And I want to share the real life use case, which I faced a few years ago and to share my learnings and my experience with reducing Power BI model size. You will see it's really 90%, so I didn't lie. You will see during the session. Yeah, at the very beginning, short introduction. My name is Nikola. I'm originally from Belgrade in Serbia, but for last almost 9 years, I live in the beautiful city of Salzburg in Austria. So it's not Australia, it's Austria. And living in Salzburg was the reason why I've chosen this nickname, Data Mozart. You probably know that Salzburg is a birthplace of this great composer. So I was brave enough to use his last name as part of my nickname. And that's why I'm trying to make music from the data. My background is traditional relational databases. I used to work a lot with SQL Server in the past and the entire Microsoft's traditional business intelligence stack. And then I transferred to Power BI and also recently to Microsoft Fabric. Privately, father of 2 kids and through football and Barca fan, as you may conclude looking at the photo on the screen. What I wanted to mention before we jump straight into the action, if you have any questions during the session, please drop them in the chat window and Atefe and Ben will interrupt me and I'll try to provide the answer. Of course, if I know the answer. If not, I can reach out offline afterwards. That's also an option. Okay, so what should you expect today from this session? I like movies and especially documentary movies, and I like to tell the stories. So it's kind of a story. It's not a regular session that you may hear somewhere else. It's a story about our favorite tool called Power BI. And in my story, you will be a hero. And our villain is non-optimal data model size. And as in most stories, as in most movies, heroes win in the end. So you will see how to overcome challenges brought to us by evil data model, resolve different issues along the way, and finally make your Power BI development a real fairy tale. So make yourself comfortable, take a seat, grab a coffee or some other refreshment, and let's start with our story. And I guess you all know the story about Titanic, right? If you don't know, you should watch the movie. Yeah, there is also a famous movie. You already watched it. I mean, who hasn't watched that? So Titanic was the most powerful, most beautiful, largest ship of all the time. And people were amazed looking at this brilliant piece of human creativity. And Titanic's story unfortunately ended almost before it started, after just 4 days of voyage from, I think it was Southampton or one place in UK to New York City. Titanic hardly hit one of the many icebergs in the Atlantic Ocean. And at first look, it didn't seem like something that can transform the greatest engineering achievement into a historical tragedy. However, Titanic didn't sink because it hit the tip of an iceberg. The main problem was under the surface, in the cold ocean water, where the largest and strongest part of this iceberg resided. Now you're probably asking yourselves, what on earth story of Titanic has with Power BI? But if you think a little deeper, we can think of Power BI as an iceberg in the cold ocean's water. Tip of an iceberg is your Power BI dashboard or Power BI report itself. Doesn't that look beautiful? Like a snowy mountain straight in the middle of the water, right? But what people don't know, people who are looking just on the surface, is that the real thing is under the surface. The biggest and strongest part of the iceberg, which provides stability of the visible part. And this part underneath consists of multiple individual but still cohesive parts which enable this part above the surface to stand strong and shine. And as I said, there are multiple individual portions down here. If you think for a moment as a Power BI developer, you will see different concepts, architectures, techniques. For example, data profiling, data modeling, data shaping. Also understanding how these some of these concepts work and implemented technically. For example, using Vertipack engine, or how you implement the business logic with DAX measures, or how you control the access with row level security. So all of these things, plus many more, of course, are under the surface. That's not visible to your end user. But we need to pay attention on doing this part properly so that we have really cohesive Power BI report in the end. And for us today in the focus will be learning and understanding VertiPaq engine. Again, you should spend your time learning other key concepts listed here, but for today we will focus on explaining the VertiPaq engine in Power BI. Now, in order to follow the story or watch the movie, you need to have some skills before you start. For example, you can't read the book in Chinese if you don't know Chinese, or I cannot read book in French because I just know to say bonjour. So we are talking about some prerequisites. And in regard to this session prerequisites, I would like to emphasize a few things. First, this is a 300 level session, which means intermediate to advanced level. So it assumes that you have some, not just basic, but intermediate knowledge and experience with Power BI and data modeling in general. And that being said, I expect from you to have at least basic understanding about relational databases, their structure, in terms of how the data is stored in the database, and of course, to be able to distinguish between rows and columns. Of course, knowledge of Power BI is also necessary to follow along, because I will often refer to some things related to Power BI development that I assume you are, as Power BI practitioners, you are already familiar with. So as we agreed that I'm telling you a story, I mean, we didn't agree, but I hope you are fine with that. This is our contents for today's session. In next 45 minutes approximately, we will cover following topics. What is VertiPaq? We'll first explain what is VertiPaq. Then how does VertiPaq store the data in Power BI? Then what we can do from our side to help VertiPaq to get the optimal data model. And finally, I will show you a demo, this real life example that I mentioned, and how I managed to reduce the Power BI data model size by this unbelievable 90%. Just by sticking with few basic, you'll see it's really basic stuff, but extremely important rules that we will talk about today. So here we are. Once upon a time in a far, far away land. Just kidding, my story doesn't start like that. My story starts with a simple question to you. Have you ever wondered what makes Power BI so fast and powerful when it comes to performance? And when I say powerful, I mean that it is able to perform complex calculations over millions or sometimes even billions of rows in a blink of an eye. Maybe you wondered, but you couldn't find the proper answer. Perhaps you were just seeing the tip of an iceberg. So today we are going to discover this part under the surface. So going back to our starting point, what is a VertiPaq? Again, you will need to wait a little more for the answer. Before we come to it, we should mark the line between row store versus columnar databases. And when we talk about the VertiPaq, VertiPaq is a columnar database. As you can see in this illustration, columnar databases stores and compresses data in a different way to traditional row store databases. Columnar databases are usually implemented in large analytical systems because they are optimized for vertical data scanning and speed of data reading process, which means that every column in its structure, every column has its own structure and is physically separated from other columns. Another important distinction in order to understand what VertiPaq is to understand the difference between two main components of Power BI's engine, which are called Formula Engine and Storage Engine. As you can see in this illustration, taken from the book Definitive Guide to DAX from Marco Russo and Alberto Ferrari, this is the process that happens once you start querying data within the Power BI report. So Formula Engine accepts the request, processes the request, generates the query plan, and finally executes the query plan. And then Storage Engine pulls the data out of tabular model to satisfy the request issued with the query generated by the Formula Engine. Storage Engine can work in two different ways in order to retrieve required data, depending which storage mode you choose for your Power BI model and tables. Either VertiPaq keeps the snapshot of the data in memory. That's the part here on the top. We are talking about this one. This is import mode. So VertiPaq keeps the snapshot of the data in cache memory. And then we can periodically refresh this data snapshot from time to time from the original data source depending on our business needs. We can refresh our models every hour, once per day, once per week, and so on. On the other hand side, here at the bottom, when you use Direct Query, with Direct Query, Power BI doesn't store any data. It just forwards the query straight to the data source for every single request. We will also mention Direct Query today, but without going deep into details, because our focus is really on how Power BI stores the data when you create semantic model. So let's first understand the Formula Engine. Formula Engine represents the brain of Power BI. As I already mentioned, Formula Engine accepts the query. And since it's able to understand DAX, it can translate DAX into a specific query plan, which consists of various physical operations that need to be executed in order to get results back. Those physical operations can be joins between multiple tables, filtering, aggregations, and so on. It's important to keep in mind that Formula Engine works in a single-threaded way, which means that requests to Storage Engine are always being sent in sequence. So to reiterate through the entire process that happens within the Formula Engine, the first step, when user clicks somewhere on the Power BI report, Formula Engine accepts the request from the user. Then it processes the request, then it generates the query plan for that request, and finally it executes the generated query. So those are 4 steps happening within Formula Engine. Once the query is being generated and executed by Formula Engine, then the Storage Engine jumps into the scene. And because it physically goes through the data stored within tabular model, we talk about the VertiPaq database, or goes directly to a different data source. If we are using storage mode, we can think of Storage Engine as the muscles of Power BI. When it comes to specifying Storage Engine for the specific table, there are 3 possible options to choose from. I already mentioned 2 of them: import mode, direct query mode, and the third option is dual mode. Unlike Formula Engine that doesn't support parallelism, Storage Engine can work asynchronously. That's one of the key differences between these 2. Now let's first briefly introduce import mode, which is the most common way and default way to store the data when working with Power BI. That said, import mode is based on VertiPaq, and table data is being stored in memory as a snapshot, as we already mentioned, and this snapshot can be refreshed periodically directly from a data source. Direct query, with direct query, data is being retrieved from the data source at the query time, which means that data resides in its original source before, during, and after the query execution. Finally, dual mode is a combination or hybrid of previous 2 options. So data from the table is being loaded into memory, but at the query time, it can be also retrieved directly from the source. So basically, Power BI keeps 2 copies of the same table, and then depending how query is generated, it will use either import version or direct query version with dual mode. So we've drawn a big picture previously. Let me explain in more detail what VertiPaq does in the background to boost performance of our Power BI reports, and what happens when we choose import mode for our Power BI tables. So VertiPaq performs the following actions. First, it reads the data source, transforms data into a columnar structure. Then it performs encoding and data compression within each of the columns. Then it creates dictionary and index for each of the columns. Then after that, it prepares and establishes relationships. And finally, it computes all calculated columns, DAX calculated columns and DAX calculated tables, and compresses them. So how VertiPaq stores the data? As you may recall from the previous part of the session, 2 main characteristics of VertiPaq are that it's a columnar in-memory database. And that means that VertiPaq applies different types of compression to each of the columns independently, trying to choose the optimal compression algorithm based on the values in that specific column. Compression is being achieved by encoding the values within the column. But before we dive deeper into a detailed explanation of different encoding techniques, just keep in mind that this architecture is not exclusively related to Power BI. In the background is a tabular model, which also works under the hood of Analysis Services Tabular and also Excel Power Pivot. So let's examine the encoding types which VertiPaq applies in order to compress the data. There are two main encoding types, plus the third one, which is the extension of one of those basic types. So first one is value encoding, then it's hash encoding, or also called dictionary encoding, and finally run length encoding, which sometimes happen on top of the hash encoding. Let's go and explain each of these encoding types in more detail. So value encoding is the most desirable type because it works exclusively with integers. And therefore, because it works exclusively with integers, it requires less memory than, for example, when working with text values. To give you an example, let's say we have a column that contains a number of phone calls per day. And the value in this column goes from 4,000 to 5,000. So what the VertiPaq will do is to find the minimum value in this range, which is in our example 4,000, and it will set this minimum value as a starting point. And then it will calculate the difference between this value and all the other values in the column and store just the difference as a new value. Now in this case, you may see that in our original column, maximum value is 5,000, which takes 13 bits of memory, whereas in compressed version, it's 1,000, which is 10 bits of memory. And at first glance, 3 bits per value might not look like a significant saving. But just imagine that this table has 500 million rows, and then multiply 500 million rows with 3 bits. I think you will then appreciate the amount of memory saved using value encoding. Then we have a hash encoding. This is probably the most frequently used compression type by VertiPaq. And with hash encoding, VertiPaq creates a dictionary of distinct values within one column, and afterward replaces real values with index values from the dictionary. Again, let's show an example. It's easier to comprehend. So what VertiPaq did, it identified distinct values within the subjects column. So this is the column here on the left, the green one. Built a dictionary by assigning indexes to those values. That's the green one. And finally stored index values as pointers to real values. I assume you are aware that integer values require way less memory space than text. So that's the logic and that's the motivation behind using this type of data compression. And in addition, by being able to build a dictionary for literally any data type, VertiPaq is practically data type independent. And this brings us to a very important takeaway. No matter if your column is of text or big integer or float data type, from VertiPaq perspective, it's the same. It needs to create a dictionary for each of these columns, which implies that all these columns will provide the same performance. Of course, if we assume that there is no big difference between dictionary size between these columns. So it's a myth that the data type of the column affects its size within the data model. On the opposite, the number of distinct values within the column, which is known also as cardinality, mostly influence column memory consumption. And then we have a third algorithm, which is called run length encoding, or RLE abbreviated, which creates a kind of a mapping table containing ranges of repeating values. Again, let's take a look at an example and understand better how this concept works. So if I have repeating values, complaint, 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 VertiPaq will store the starting position and how many consequent occurrences of this value we have. In this case, 4, and then we have new contract. Yes, I made a mistake. So here, new contracts should start from number 5, and then we have 3 repeats of bonus minutes, and so on and so on. So that's the logic behind row level, not row level security, run length encoding algorithm. Sorry. No matter how this tool looks, it's highly dependent on the ordering of the column. So when you talk about run length encoding algorithm, it usually happens after hash encoding, that VertiPaq thinks that it makes sense to additionally compress the data. So when the data is ordered in that way, that run length encoding will achieve better compression rate than just using hash encoding alone. So this is process that happens in reality. So first it's hash encoding, and then on top of that, if there is a need for additionally compressing the data, then run length encoding will kick in. Before we jump into the demo, few more things to explain how VertiPaq thinks and how it decides which compression algorithm to use for a specific column in the model. First action is that VertiPaq will scan a sample of rows from the column. And if the column data type is not an integer, it will look no further and it will always use hash encoding. If the column is of integer data type, then some additional parameters are being evaluated. So if the numbers in sample linearly increase, VertiPaq will assume that this is probably a primary key column and it will choose value encoding. If the numbers in the column are reasonably close to each other, so number range is not very wide, like in our example from previous slides with 4,000 to 5,000 phone calls per day, VertiPaq will use value encoding. But if values in column fluctuate significantly within this range, let's say we have numbers between 1,000 and 1 million, then value encoding is not an option and VertiPaq will apply the hash algorithm. Process of re-encoding I'll skip because I think maybe it would be too much explaining this and too technical, but there are certain circumstances where VertiPaq can make a mistake and then needs to do a re-encoding from scratch. So here is the list of parameters in order of their importance that VertiPaq considers when choosing which algorithm to use. First is number of distinct values in the column, or cardinality. Then it's data distribution in the column. Remember, column with many repeating values can be better compressed than one containing frequently changing values, because as you already explained, when you have data sorted, then round length encoding algorithm can be applied. Then number of rows in the table, and finally column data type, which impacts only dictionary size. Another structure that we have in our semantic models, they also play a big part in the size of the model. And then why they play a big part? Because first of all, they enable quicker transfer of the filter context between related tables. But the most important thing to keep in mind about relationships is the higher cardinality of the column that makes part of the relationship, the higher the cost of this relationship is. So when cardinality of the relationship exceeds 1 million, then users may notice slower performance in the report. And one of the reasonable solutions could be to create pre-aggregated tables with different levels of detail so you can avoid expensive relationships at the query time. I'll also skip materialization, but because I think it's really advanced concept, it's a step in query execution process that is typical for columnar databases, and it also works the same way in VertiPaq Engine. There is a temporary storage called data cache, and depending on how much data is stored in this temporary storage, your report may run slower or faster, but we will examine this during the demo. Aggregations usually help storage engine to work faster. They represent more reorganized versions of the source table. So you can have multiple different tables related to same original table. And by pre-aggregating data on different levels of detail, we can help storage engine to work faster and scan the data in more efficient way. A simple example of how using aggregations can reduce the both number of columns and rows. In this case here, I have data displayed for every single date, and then every single subject, and then every single user ID. This one for this result set has 7.3 thousand rows. If we aggregate data and show the total number of chats per every single date, then instead of 7,000 rows, we have 45 rows. So grouping and aggregating data will reduce the number of rows and reduce the overall data model size. It's not for optimizing DEX calculations, it's for optimizing data model size. And now I think we laid a solid theoretical background for the things that come now. It's time to get hands dirty and see how all of these concepts and techniques work in reality. So before I jump into Power BI Desktop, just to mention again that this demo is based on a real life use case, which I faced a few years back when I was working for one of the companies here in Austria. And the problem was with the size of PBIX file on our report server. So the company was using Power BI report server. And file size dramatically grown since the report had been first time introduced. So I was involved in trying to find a solution. And before we proceed, just to mention that I've created separate PBIX files for each of the phases in data model size optimization. I did that so we don't need to work on one single file and wait for Power BI to apply all changes we made during the process, because sometimes data reloading may take a while and we have a time constraint. So I already prepared a few files to show you the difference in performance between each of them. So let me move to my Power BI desktop and let's start with the first file. Let me check if we have any questions. As far as I see, no. Ben and Atefe will.
Yeah, for now it's good. It's good for now.
Okay, perfect. Thank you. Thanks for confirming. Okay, so let's start and let's first take a look at our model. It's a very simple model, so I've intentionally reduced the complexity. In reality, there were more tables involved, of course, but here I have a fact chat table that contains the information about the chats performed by customer support department in the company. And I have just two-dimension tables, DIM product and DIM country. So super simple model, 3 tables. And our fact table has 9.2 million rows, or let's say 9.3 million rows. So that's not considered a super large table in Power BI terms. It's not a small one, but also it's not a big one. So it's a medium-sized table, 9.3 million rows. To be able to follow along what is going on with our data model size, I will use DAX Studio. And I sincerely hope that you are also using DAX Studio in your day-to-day Power BI work, because it's an amazing tool and it's a free tool. So if you're not using DAX Studio, please go and grab it on daxstudio.org. And yeah, your life will be much easier. If you install Power BI Desktop and DAX Studio on the same machine, you can access it directly from Power BI Desktop, which I'm going to do now. From External Tools tab, I will open DAX Studio and automatically connect to this model here. Okay, so one of the coolest parts of DAX Studio is extension called VertiPaq Analyzer. So it's a built-in feature within DAX Studio that lets you analyze the size of your Power BI model. So if you go here on Advanced tab on the top and then select View Metrics, what is going to happen in the background? The analyzer will run a series of dynamic management views and get the data about your data model. You can do that, of course, on your own without DAX Studio, but here it's more user-friendly, more understandable when you do it from VertiPaq Analyzer. Now I first want to show you one thing, and I want you to remember this picture. In fact, not a picture, just a number. You can see that the starting point of my PBIX file is 1.83 gigabytes. So that's total size of our data model. Pretty massive, huh? Some of the things that are also not included here, that let's not complicate things, but let's start with 1.83 gigabytes. This is our base measure that we are going to use to compare optimization process. How do you optimize your Power BI model? Of course, you need to take a look and see what are the most expensive columns, what are the most expensive tables in your model. So here we are focusing on our fact chat table. That's the most expensive one. As you see, cardinality shows the number of rows in the table. And if I expand the table, I see all the columns that are part of the table. And I can immediately see that there are two columns which are super expensive in terms of memory footprint, date TM start and date TM start UTC. Each of them takes 441 megabytes. So these two columns takes almost 1 gigabyte of the memory. This one, source ID, is also expensive. Session referer is expensive. Let's focus on these four here at the moment. Now you need to understand what this column represents in your semantic model, right? So you open the model and you see that date TM start and date TM start UTC. Let's go and open our model again. I'll go to Power Query Editor just to understand what we have in our model. So in my fact chat table, you can see that my date TM start column and date TM start UTC column, this one stores the date information when the chat started in its original time zone. This one simply converts it to UTC. And both stored to a second level of precision. Do you really need, or do your users really need to run analytical reports on a second level of precision? I would argue probably not. Maybe sometimes, really in some rare occasions, but in really 99.999% of cases, analyzing data on a second level in Power BI report doesn't make sense. That's first thing. Another thing is, do we need both time columns, date time columns here? Definitely not. So I'll keep this date TM start UTC because it's like a universal time zone. And then from there, if necessary, on the report level, I can make conversions to other time zones. So I don't need this date TM start UTC column. I simply right click on it and remove this column. Then let's take a look at other potential problems here. We have a referer column. If you take a look at this column, is this useful from end user perspective? Can they figure out something based on this information the way it is stored here? Definitely not. So referer and session referer columns are completely useless. So they were taken from the original database as is without any transformations, and therefore they are completely useless. Another thing we have here, we have a chat ID column, which is a surrogate key from a data warehouse where data is originally stored. And then we also have a source ID. This is a business key or alternate key that comes from the original source system. So in no Galaxy, we need both of them, right? So I would argue that if we need any of those two, but in any case, we don't need both of them. So I'll take also this source ID column outside from my data model. Last edit date, this is the information when the record was last time updated in your data warehouse. So this is absolutely useless for Power BI reporting. And when I asked users if they need last edit date, they were not even aware that this column exists. So I also removed this column. So what I did, I removed 1, 2, 3, 4, 5 columns. And the last one that I can remove is chat variables, because again, this is a bunch of, I don't want to load more. This is a bunch of JSON style stored records. Again, completely useless from an end user perspective to keep them in your Power BI report. So essentially, I removed 6 columns, and let's hit close and apply and see what happens with the size of our data model. I just included this one, this card here in my report, so I can follow that the number of the records that I want to display does not change, so we don't violate data accuracy. Let's go again to our to DAX Studio and to Vertipack Analyzer. I refresh the metrics, and let's go to summary. Instead of 1.83 gigabytes, it's now 647 megabytes. And so just by removing some of the unnecessary columns, we shrinked 2/3 of memory footprint. And that's what I wanted to stress here. I want to go shortly back to presentation. And I always like to use this analogy with pizza. Let's imagine that you're preparing a delicious dinner for your friends. So you invited them for a tasty pizza, but before you make the dish, you need some ingredients, right? So what goes into a regular pizza? pizza bread, tomato sauce, ham, cheese, right? Maybe you need some extra ingredients for some of your guests, such as, I don't know, pineapple or corn or egg, olives, because you are a good host and you want to satisfy all your guests' needs. Okay, what's the next step? We are going into our local shop to buy all of these things for our perfect pizza. But while we are walking through the shelves in the shop, we see a beer. Do we need beer for pizza? I mean, it's always nice to have a beer, but do we need beer to make the pizza? Few steps more and you spot chocolate ice cream. I love chocolate ice cream. I really do. But again, do I need it for my pizza? That would be a really weird pizza if you ask me. So what is the moral of this pizza story? You should focus on those and only those things you really need. Translate it to your Power BI development. You should focus only on data your report users really need. So you can put in something extra, such as pineapples on top of your pizza. In some circumstances, when you think that it would bring additional value to your report or your dashboard, but carefully evaluate if that brings more benefit in the final outcome. Would you buy a whole pineapple and put it all over your big pizza if you have only one guest eating pineapple pizza and then maybe 10 others who don't like pineapple in the pizza? Or should you maybe prepare a smaller pizza for this one pineapple guest without disrupting the main dish? I believe that it's always useful to keep in mind this pizza comparison when you are considering which data to put in your data model. Now going back to our data model, and truth to be said, if I go here and expand my factor table, also some other columns can be removed from here. But let's focus on other techniques to reduce the data model size. And I mentioned in the first part of the session that the biggest problem for your data model size, the biggest impact is cardinality, number of distinct values within the column. The rule of thumb is the higher the cardinality of the column, so the more distinct values we have in it, it's harder for Vertipack to optimally compress the data, especially if we are not working with integer values. There are multiple techniques for reducing the column cardinality, and I want to show you a few of them. I'm using SQL to demonstrate how you can reduce the cardinality. So there are at least 3 possible solutions to choose from. So if your key column is of high cardinality, what you can do, you can use division and module operations to reduce the cardinality. So in this case, instead of one column that contains big integers, I have 2 columns. This one has cardinality of 1, right? Because we have just one repeating value. And then this one also has 10 unique values like the original one, but instead of 7 digits, we store just 3 digits. Then we can also split decimal column values on decimal point. In this case, we have, instead of having decimal numbers, we are storing integers. That saves the space. Finally, this one is one of the most commonly used techniques for reducing the cardinality, splitting date time column to date and time. So as you see in this case, I'm creating 2 columns. One takes only this part, so only date, stores the date, and the other one stores hours, minutes, and seconds. The idea is, because you have the limited number of seconds within one day, this column cannot have cardinality more than 86,000 and what is the number of seconds within 24 hours. So this one is commonly used technique to reduce the cardinality. So those are just some of the options that you can use. And if I go back to my next Power BI desktop file, here my users needed not data on a day level of detail, but level of detail of hour. So I needed to round the data to my to the closest hour. So how I did it? Let me show you. If we go to Power Query, and this is the SQL query that I've generated. So I'm using combination of date add and date diff functions in T-SQL. You can do the same thing in Power Query, But as I mentioned, my background is SQL, so for me it's easier to do it in SQL. But you can do the same thing also in Power Query, and it will perform the same. So essentially what I'm doing, I'm rounding values to the closest hour. And this is how it looks within a column now. Instead of having, for example, here 3:24:31, I have 3 a.m. for all the records that are closest to this hour. So what happens if I open this file in DAX Studio? Let's see the size of this file. Again, going to advanced and then view metrics. So this one is 223 megabytes. Remember where we started, 1.83 gigabytes. So we got rid of some unnecessary columns. We fulfilled the request from our users to have data on our level of precision. If I just used their level of precision, so if my users don't need to analyze data on our level, this one will go to 150 megabytes. But that's what I first did. I didn't ask them, I just rounded to a day level of precision. But then they complained because the idea of this report was to assign certain number of customer support agents based on the time of the day. So they needed data on an hour level. But they don't need minutes, they don't need seconds. So you get rid of minutes and seconds, you get hour. And what happens is that your date PM start UTC column, instead of 8.8 million distinct values, now has 32,000. And instead of 440 megabytes, it's now 19 megabytes. Okay, so that's already a huge saving. One more thing that bothers, and it should bother you, whenever you have a column that doesn't provide any business value. In this case, this is chat ID column. As I already mentioned at the beginning of the demo, that's just a surrogate key and information that you stored in your data warehouse to be able to uniquely identify each row. But it doesn't have any business value. So it's just a meaningless integer number. There are any relationships based on this column. So why on earth I would keep this column in my data model? It takes 64 megabytes. So what I finally did, I got rid of this column, this surrogate key column. And if I open finally my DAX Studio once again, this is the final version of, or almost final version of my file, of my solution, and go to advanced and view metrics. Let's see the size. It's 161. So it's less than 10% of where we started. So you see that I didn't lie when I told you that we will reduce the data model size by 90%. It's even more than 90%. Just by sticking with some very simple and basic rules. So nothing fancy, nothing complex, really sticking with some basic rules, and we managed to help VertiPaq to optimally compress the data. Finally, you may notice that here I have these auto date time tables, those hidden tables created when you leave this auto date time option enabled. And that was also the case here. So what I did finally, I just uncheck this auto date time option. You see that number doesn't change, so data accuracy is not affected by applying all of these techniques. And if I check one last time, it's few more megabytes, in this case 157 megabytes. That's our final state and final memory footprint for this model. Maybe some of you now think, okay, Nicola, what you did here is you talked a lot about VertiPaq, encoding types, cardinality, and so on. But what you just shown us is basically just removing unnecessary columns, nothing special. And you're not completely, but almost completely right. But again, in 95% of cases, when you're performing data model size optimization, simple removal of unnecessary columns and unused rows will be enough to get the job done. Trust me, I've been there, so I can guarantee that. That should be always your starting point when dealing with data model size optimization. In those remaining 5% of scenarios, you would maybe need to apply some more advanced approaches, such as cardinality reduction, using some of these techniques that I mentioned, splitting columns into 2 columns or rounding numbers, and so on. So going back to our presentation, let me find it. To summarize what we covered today, here is the list of general rules you should keep in mind when trying to reduce the data model size. First, again, keep only those columns your users need in the report. And just sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you just seen in our demo, sticking with this one rule helped us make astonishing savings. Always remember pizza comparison. Try to optimize cardinality whenever possible. The golden rule here is test, test, test. And if there is a significant benefit from, for example, splitting one column into 2 columns or substituting decimal column with 2 whole number columns, then do it, yeah. But also keep in mind that if you do that, then you need to rewrite your measures to handle those structural changes in your data model. So if your table is not big, or if you have to rewrite, I don't know, hundreds of measures, maybe it's not worth splitting the column. Let that be your last island, you know. Same as for columns, keep only those rows you need. For example, I know if we ask our users which data they need, they will probably tell yes from last 35 years. But in reality, they don't need data from last 35 years. So talk to your users and ask them what they really need. Do they need last 10 years of data or last 3 years of data? That will also reduce your data model size. Aggregate data whenever possible. That means fewer rows, lower cardinality. So all these nice things we were talking about and we are trying to achieve. If you don't need hours, minutes, and seconds level of precision in your Power BI report, don't import them. Aggregations in Power BI are very important and wide topic, which is out of the scope of this session, but generally try to aggregate your data whenever possible. Avoid using calculated columns. I need to be more specific here, DAX calculated columns. Simply said, they're not being optimally compressed. Instead, if you need to implement any additional calculation logic, push it as upstream as possible. Do it in SQL database if you can, or if you cannot do that, do it in Power Query. That will also compress the data before it loads it into Power BI. User proper data types, no matter how simple this sounds, if your data granularity is on a day level, there is really no need to use date time data type for your columns. In these circumstances, just a plain date type will be completely fine. And finally, disable auto date time option for data loading, because this will remove a bunch of automatically created tables in the background. Okay, any questions?
Yes, I can see the question here. I missed something. So which tool did he use to do to the request SQL?
If we are talking about this one, that's SQL Server Management Studio, which is a free tool that you can download. This is SQL Server Management Studio, and it's usually used for manipulating data in your relational databases. So you connect with SQL Server Management Studio to your database, and then you run queries.
Yes, thank you. So
no problem.
Another question is, for instance, age range. It is better to have a DAX switch based on the birth year or age range column?
From a perspective of data model size, it's better to have age range column. From the perspective of speed of execution, you need to test, because it depends how many values you have and so on. But from the optimal compression size, it's better to have age range column.
Okay, thank you. I don't see any other question. And thank you so much, Nicola, for your time and for accepting our invitation. So I hope we will have you again soon in our meetup.
Happy to join. Happy to join whenever you think something that there is something interesting I can share. I'm happy to join. And from my side,
Yeah.
thank you to two of you guys, and thanks to everyone for joining the session. I hope it was useful.
Yeah, for
Yeah,
sure.
thank you so much, Nicola. And before you leave, please give us a feedback in the chat if you learned something today, and if you have new ideas for optimization. Please let us know in the chat. It would be very interesting for us to read that.
Okay, so I will take these 3 minutes to first of all thanks all people that they are attending. We had an amazing presentation, speaker, and people here. And also, I'm pretty sure people here will use the Access Studio if they didn't use it so far. So
yeah, go for it. Go for it. Yeah.
Yeah, they will use it, and we will have another great speaker next month, Pragati Jain. She's an MVP, and we will see you all soon. Thank you.
Thank you, everyone.
Thank you. Have a great day. Bye.
Yes, thanks again, Nicola. Bye.
Thank you. Bye-bye. Have a good one.
You too. Bye.
Ciao.